Hello everyone, this is Vijayasri working as an assistant professor, Department of CSIT, MLR Institute of Technology. In today's session, we are going to discuss about searching techniques in C, that is linear search. Overview of the session, linear search. We'll discuss definition, what is the working principle, time complexity, pros and cons. Then definition, linear search is a simple searching algorithm that checks every element in the list sequentially to find the target value. It checks the every element in a list sequentially. We can say it is a sequential searching algorithm also. Then working principle, it starts from the first element. Let us suppose this is array A. Then I want to search the element 5 which is present in the array or not. So using a linear search, the working principle, it starts with the first element. This is the first element, 0, 1, 2, 3 and 4. That is the first element. It will search the element to get until it get the target element by one. Compare the target value with each element in the list one by one. That's why it is called as a sequential. So let us suppose I want to search whether 5 is present in the array or not. So it will search sequentially, that is one by one, till we find the target value. And one more thing is, it can be applied both in sorted list and unsorted list. Means here I consider all the elements of the array are in sorted list. We can also take an unsorted list. We can perform a linear search. Suppose 12, 2, 1, 97, then 5. This is unsorted list. Here also we can, linear search can be performed both. It work on both sorted list and unsorted list. Then time complexity of linear search. Best case is order of 1. So if we found the element in the first index, first element only, the target value, we reach the target value, then it is the best case, order of 1. Average and worst case are order of n. Space complexity is order of 1. Then pros, it is simple and understanding. Then no need of sorted data. It can work both on sorted list and unsorted list. In place of searching requiring no extra memory. Then cons, insufficient for larger data set. If you are having a large data set, it is inefficient. If it is a larger data set, we can go with a binary search. The cons is inefficient for larger data sets due to time complexity. Slow compared to the other searching techniques like binary search, especially if we are having a larger data set. Then working principle, let us suppose here consider an array. How the linear search work? Searching means we are finding our target value. Suppose this is the array. Generally we will do in a 1D array. So this array 5. Here I am considering the 5 as the size of the array. That means this array contains a 5 values which is of type integer. Index starts with 0, 1, 2, 3, 4. So the values here I am giving as 1, 2, 3, 4 and 6. These are the values which I have provided here. Now I want to search whether the target value is a 4 present in the array or not. So consider this is the key value. In a sequential searching algorithm, it starts with the first element and it checks one by one, because it is a sequentially, it will search till we reach the target value. And here we have a two conditions. So first I want to search whether 4 is present in the given list or not. So it will search from the first element, that is 1, the key element, the target element is 4. Now, is 1 equal to 4? No. So, the control goes to the next because it searched 1 by 1 in the array. So, 2 is 2 equal to 4? No. So, it will go to the next element, that is 3. Is 3 equal to 4? No. So, it will go like this. Now, we have a 4. Is 4 equal to 4? Yes. So, if I found the target value, that means the key value, then I have to print like the element or the target value. The element is found, where either we can print the index or we can print the position of that value. So, if I want to print the index, then the element is found at index. Index, I want to print this. Or the position. Position is 1, 2, 3, 4. So, I plus 1. Index plus 1. This is one stopping condition. That means if we found the value. Then another stopping condition is, let us suppose now the key value is 8. Whether this value is present in that array or not, I want to search using the linear searching technique. So, linear searching technique, it starts with the first element and goes on 1 by 1 till we found the target value. So, the first element is here 1. Is 1 equal to key, that is 8? No. Then 2 equal to 8? No. Then it goes on the next value, that is 3. Is 3 equal to 8? No. Then we have a 4. Is it equal to 8? No. Then we have 6. In this case, no. So, we reached end of the array. Are there any elements? No. We reached end of the array. That means the element is not found. So, next stopping condition is when we reach end of the array. That means we reached the number of elements, n. Then we have to print as the element not present in the list. In this way, the linear search algorithm works. So, here we have a program. So, we'll do this in an array. Here I declared array of type integer. Then n is a number of values. Then I, the target value here I consider as a key, and I consider a flag value. Flag is it takes boolean values, either 0 or 1. So, number of elements are 5, suppose. So, the 5 are here. I have those 5. I am taking that only as an example. So, the array name is A. 0, 1, 2, 3, 4. Now, the values here are 1, 2, 3, 4 and 6. Now, the key. So, using a for loop, we can scan the values. Already we discussed about that in the arrays concept. Then, what is the element? What is the target value? I want to search whether it is present in that list or not. That is the key. Key here I have given as 3. 3. So, we have to check whether it is present in that array or not. But all the elements are not stored in the same location. They are stored in different index. So, we need a for loop. For I equal to 0, I less than n is 5. Condition is true. So, the control enters into the loop, body of the loop. In that we have a if condition, that is key equal to a of I. Here key is 3. Equal to a of I. Initially it starts with the first element, that is a of 0. In a of 0 we have 1. Is 3 equal to 1? No. So, I is incremented by 1. It goes to the next element. In that we have a 2. Now we check whether 3 is equal to 2. No. Then it goes on one by one because it searches sequentially. Then 3 equal to 3. Now I found the value. But what happens here? Still we are true in a loop. When the control comes out of the loop, when the condition is false, again I plus plus, now I becomes 3. Now it is 4. Is 3 equal to 4? No. Again I plus plus, now it becomes incremented and the value is 5. No. After finding the element, no need to compare these two with the key value. So if I want to stop the loop, if I found the element, I want to stop the loop. So that here I consider flag is equal to 1. Initially flag is 0. Now I consider flag is equal to 1. Then I used break. Break is having a property that it can exit from it stops the execution from the loop. It exits from the loop. So when I found the key, I am using a break statement. Now, if I found, then let us suppose I have a 7. No, 7 is equal to 1. No. Then 7 equal to 2. No. Then 7 equal to 3. No. Then it is incremented by 1. Again 7 is compared with the next element. We reached end of the array. So we can write the condition as, instead of writing this, we can also write, if this condition is true, that means I found the element in the given list. Then we can write printf element found at, either you can print the index, that means location, or the position of the target value. %d, I. Here I am printing the position. The position of that value is 2. It will be printed. If not, this is one condition. If the element is not present in the list, that means when it is not present, when we have reached the end of the array. Here we have reached end of the array. So in that case, we can write if number of elements, if I is the index, if it or equal to n, then the element is not found. Instead of writing these two, we can also use, here I used a flag variable. If I found the key, if I found the element, then flag becomes 1. No need of searching the remaining 2 in this case. So I used a break statement to exit from the loop. Then if flag equal to 1, when this is 1, when the element is there in the list. So flag equal to 1, number is found at a location, else number not found. In this way, we can search the element using a linear search technique. It can be applied for, it can work for both sorted list and unsorted list. In the next session, we'll discuss about bubble sort.